Okay, it's recording now, right? Now we can, once we have this form, we can see what the radius of the circle is and the coordinates of the center of the circle are, right? So that's why this is useful. You can even write now, what is the radius of the circle? I can see what the radius is, root 49, that is 7. What is the center? Center of the circle is 3, comma minus 5. I mean, you can visualize where it is on the grid and how big it is. You can even do a little sketch. But when having the standard form, there's nothing much you can say about it. Right, okay? So hope that is clear. Before we go into doing some questions related to all of it, real problem, isn't it? And this has never happened, I mean, this much. I don't know what it is. Okay, let's just get into it, okay? No point talking about it. I hope the recording is still going. Here's the problem. This the next little theory part. We're going to do as I'm going to give you as a little problem to solve. Okay, so let's put the topic. The topic is this is the last topic. This is under circles, a subtopic. Finding the equation. Finding the equation. Yes.
Miss, for the previous question, I first found the center and radius, like not using the method, and after that wrote it in the center radius.
Say that again. I didn't understand what you're saying. In the last example, which is this, and then
Miss, I first found the center radius and the
center radius by looking at these two terms.
center radius and the yes, Miss. After that, I wrote it in the center radius.
Yeah, you can do that too, but for that you have to like memorize this form. Like you have to know, yeah, that you can do too. If you know that your terms have this format, right? So this minus 6x, should it is minus 2ax. So x is there, minus is there. So this 6 is 2 times a. Then what is a? Remember, a is the x coordinate of the center. You can like argue like that. By matching up with the form, you can get what a and b are. And then for c, you by matching up with that, you can figure out the r. You can do that too. That's another way too. But this, here what we did was, we just turned it into the form so that automatically they appear in your form, the center and the radius. What Afra, was that Afra? No, Afra, right? Yeah. What Afra is saying is that she was comparing with the form. You can do that too. And then again for plus 10y, it takes the form minus 2by. So the y is there. Minus 2b has to be plus 10. Like by matching those up, let me see what you are saying. Oh, okay. So Afra, you can see what Afra is saying, right? Are you maybe it's because my connection is poor. It's the end of the month, right? Maybe my data is, what's the date today? 20. We are at the end of the month now. I'll check that. Maybe that's but could that be a reason why this is getting stuck? No, it won't get stuck because of that. The connection would be poor. My quality would be poor. I'm very sorry if that is happening now. If my either the audio or the video is not very strong, I can try changing the router. I have another router. Shall I change the router? Give me a moment. Do you all get that message from your side saying that my connection is poor? Let me change the router. Okay, I just changed it to a different one. See whether there is an improvement or whether it is worse. Okay, Umasha didn't get it. Afra got it. No? Let's see, okay? So as I was saying, now this is gone. ID time is gone. Give me a moment. It's gone because I changed the router. Give me a moment. I have to change the router of this too. Should be okay now. So still it's there, right? I don't think that changing the router helped. Yeah, I know. Okay, let's just do this, okay? Let's just sail through the wind, okay? Finding the equation. Let's somehow finish this today. We will take this challenge. Finding the equation. You can see, right? Are we still recording?
Yes, ma'am.
Yeah. Finding the equation of a tangent to a circle. This is a long topic. To a circle. Finding the equation of a tangent to a circle at a given point. At a given point. We are going to do this as a problem. I'm not going to teach you the theory behind this because you can do this yourselves. Let's do it as a problem. Here's your problem. I'm going to give you a problem to solve. I give you a circle. Okay. Here's my question. My problem is find. This is your topic. Finding the equation of a tangent to a circle at a point. Here's my problem. Find the equation of the tangent. Find the equation of a tangent. Remember, tangent is just a straight line of the tangent to the circle. I'm giving you the circle equation. To the circle, x squared plus y squared equals 25 at the point P. The coordinates of P are 4, 3. So I'm giving you the equation of the circle. I'm giving you a circle and I'm specifying a point on the circle. You have to find the equation of the tangent line going through that point. Okay. Now, I'm giving you the equation of the circle means I'm giving you the coordinates of the center, 0, 0 in this case. and you have the radius. Radius is 5. And then I have given you a point on the circle somewhere. Let it be here. We don't care where it is. 4, 3. 4, 3. The point P right here. I want you to find the equation of the tangent line. What you already know is, you know that, sorry, that is just that point. You know that this length is 5 because that is R. Okay? Remember, the tangent and the radius, they are perpendicular. So that's a hidden information. You're supposed to know it from circle theorems. Any tangent drawn to a circle and the radius drawn to the tangent point, they are perpendicular. You have to find the equation of this line. Can you try it? You will be able to do it because you did a similar question in the homework. Remember, you found the equation of the perpendicular bisector, something like that. So if I direct you, no, let me not direct you. Can you try? You want to find the equation of this line. You already have a point on that line. If you can find the slope, point slope form. It's very easy. Ha! Y minus 3 equals, that's correct.
Question.
That looks correct.
Miss, I got the same answer.
Yeah, right? How easy is that? Because you find the gradient of that line, the line along the radius I have drawn here, this line, because you have 2 points for that, 0, 0 and 4, 3. You find the M for that, then you know you have the M for the perpendicular line, the negative reciprocal. You have a point, you put in the point slope form, right? So if I mean, that's so easy. You didn't even need the 5. That information was not needed. So if you can find the M for that, 3 minus 0, 4 minus 0, it's 3 over 4. Then M for this is minus 4 over 3. Then you put in the point slope form, y minus 3 equals minus 4 over 3 times x minus 4. Right? Very good. See, this was a theory. Throw the theory away. You can create theory. I mean, theory is just using the existing knowledge, trying to solve a new problem. You get a theory on. So you have the theory of finding the equation of a tangent drawn to a given circle at a given point, right? You just did that on your own. Okay, that's the end of. We have a little thing which is not there in the syllabus, but I might take it up again because I have seen one time that they had asked something related to this thing. I'm going to for now leave it aside. Let's go to our. I'm going to quickly next time. Next class, we're starting the next topic, which is in our sequence in our sequencing of the topics. The next topic is series and sequences, which is the 6th topic in your syllabus. Oh, I didn't give you this, right? I need to give you this too, the syllabus booklet. Anyway, so let's go, and now you can solve all the problems in both booklets. As I said, under quadratics, let me take you to that. Let me take you to, I don't have it now. Give me a moment till I open that. And let me have that. Give me a moment. I have to open the booklets because I restarted. Everything is gone now. Here that is. Right. Yes. Okay. All the problems in both quadratics and coordinate geometry, now you can solve. Okay. So you can just try all of them out now. I will show you. I told you that it's very difficult to find questions just from quadratics. A lot of quadratics related questions are under coordinate geometry problems. Okay. So if I take you to the quadratics booklet, let us do a few problems where everything that we have learned so far would come together. Okay. Now I hope you have picked out the questions that we have already done. This first question, did we do? Can someone check and let me know? In the quadratic booklet, first question.
No, miss.
No, right, let's do it. Okay. So I don't know whether you are maintaining a different book to do questions. I did not specify that. It would be nice if you are doing the questions in a separate book, but it's okay if you are doing in the same notebook. It's up to you, your choice. Just maintain your notes and question books and exercise books any way you want. They just need to be in order and organized and neat and all that. No hard and fast rules. Okay, let's look at this first question. Okay. Read the question. Find the value of the constant c for which the line, so that's a line, for which the line y equals 2x plus c is a tangent to the curve y squared equals 4x. Now, y squared equals 4x is a curve. Do we know by looking at the equation what kind of a curve it is? Whether it's a parabola or a circle, those are the two that we know, or that it is some other shape? Are you able to recognize? Is it a parabola? I mean, you don't even have, it's not a parabola, it's not a circle, it's some other curve. You don't, I'm just discussing it here. You don't have to stop and think, what kind of a curve? You don't have to do that, okay? That has nothing to do with solving this given problem. You don't have to know how what the shape of the curve is. So what do we have here? We have to find the value of the constant for which the line is a tangent to the curve. Now notice that constant c is the y-intercept of the line. So by changing the intercept, you can just move the line anywhere you want on the grid. You can't change the slope, but you can, by putting different values for c, you can move it up and down. So you have to find the value that c must have so that this curve is fixed. You have this curve y squared equals 4x. What's the value of c so that it becomes a tangent to the curve? So what this means is, if when you solve the two equations, they should have only one intersection point if it is a tangent, right? It should have only one intersection point. So can you try doing it? What you have to do is you solve them simultaneously, get that single quadratic of one variable, and you have to talk about the discriminant of that. You have to make the discriminant equal to, or what is the condition? For you to have one solution, you have to make the discriminant equal to 0. You find the value of C such that the discriminant of that quadratic is 0. Okay, I will start it on the on my paper writing pad, but you can go ahead of me. Let me just write the two equations. Y equals 2x plus C. It's my line. And then I have y squared equals 4x. That's my curve. Did you start doing it? Okay, this is my line. This is my curve. If you want a diagram, like suppose your curve, doesn't matter, just draw a curve like that. You want this line to be a tangent so that it has only one cutting point. This is your curve, this is your line. What needs to happen for this to happen? Shall I substitute 1 in 2? So I'm going to solve these two simultaneously. Substitute 1 in 2. So I'm going to put this for y here. 2x plus c squared is equal to 4x. Now that will give me my quadratic. 4x squared plus 2 times 4cx plus c squared. Let me bring this also to this side, is equal to 0. That's my quadratic. Let me arrange it in the nice ax squared plus bx plus c way. 4x squared. My x term, I will put the x separately. My x term is 4c minus c, isn't it? Sorry, 4c minus 4. I simplified these two together by factoring the x out. That's my x term. X square term, x term, and the number term is c square is equal to 0. So here's my a, here's my b, here's my c. A is 4, b is 4c minus 4, c is c squared. What needs to happen? The discriminant of this, let's write it. For the line to be a tangent to the curve, what must happen? The discriminant, of this equation, of this quadratic equation, must equal to 0. Okay, so I'm using these 3. Let me write my b squared minus 4ac must equal, I'm setting it equal to, I'm doing it, I'm making it equal to 0. I know that has to happen if the line needs to be a tangent. So that's the condition. Here's the condition. This is the condition. I'm setting it up. So what is b squared? B squared is 4c minus 4 squared minus 4 times a times c is equal to 0. Now don't confuse, there is a c already in the question and that whole thing is the c. Now you have to solve this and find the value of c. Okay, so Aisha has gotten C equals half. Let's see. Looks like you get another quadratic equation here to solve, right? 16C squared, 32C plus 16 minus 16. That gets cancelled. That's cancelled. 32C is equal to 16. C is equal to, yeah, half. Right? C is equal to half. Okay. I want to show you, let me take you to what we did here. I want to show you, I need to, sorry. I have to open it first. Let me stop sharing this and open my Google. Give me a moment. Okay. So you all got half, huh? So let me open a Desmus. I want to show you what we did here. I will show you how this curve and the line. Because you have to understand what went on here, right? You have to see it. So let me share the screen now with Desmus. Okay, I will graph y squared, the curve, okay? Y squared equals 4x. There it is. That's your curve, okay? Actually it is a parabola, but it's this way. So it's not a quadratic. It's the inverse of a quadratic. And this is not a function. It's just a, remember, if you think of it, think as a function, this. So many messages. So many messages. Wait. Yes, Afra. Yeah, I can see that you're discussing about how our problem here. I'm very sorry if it is annoying. It is annoying to me as well. But please understand that it's out of my control. I will see whether it is something that is due to anything wrong with my computer. Okay. Right. So this is your curve, y equals 4x curve. It's fixed, right? It's fixed. Y equals 4x. Y squared equals 4x. And your line equation is, they said y equals 2x. That's the line. Now I didn't add the c. If the c is 0. Now by changing your c, now let me put like plus 4. There, it went there, right? By changing it to 3, by changing that I can move it, right? If I do minus 7, it goes there. So by changing it, I can, the slope is the same. I can, by changing the intercept, the number intercept, I can just move it up and down, and then it goes like that. So if I put half plus half, see what happens, it will become a tangent. If I put plus half, then it's a tangent, okay? So that's what you found. You found the value of C so that the line becomes a tangent to that curve. Okay, that's what you did in this question. Let's go back to, I just closed. Let's see if I have mine. Give me a moment. I will quickly open the quadratics tab again, quadratics booklet again. What I will do is, let me assign you some homework. Right. Do you see the booklet? Do you all see the booklet?
Yes, miss.
Yeah, okay. So number one is what we just did. Number two, can you check whether we have done it? That is a quadratic equation in disguise. That's completely from quadratics, nothing to do with coordinate geometry. Here are some questions that have both quadratic knowledge coming in and coordinate geometry, this intersection business coming in, okay? So please mark number 3, number 4, number 5, so let me also write them down. I'm assigning 4, 5, and 8. Shall we also do 6? I'm sorry. So 3, 4, 5, 6, and 8. 3, 4, 5, 6, and 8. They all have this something to do with this intersection. And then whenever that comes, it gets connected to quadratics. You know, if you're talking about the intersection between a curve and a straight line, you can talk about the number of intersection points by considering the discriminant of that quadratic. So these are problems that connects your coordinate geometry knowledge and also quadratics knowledge, okay? So number 3, 4, 5, 6, and 8, I'm going to leave for homework. I will go back to